Kingsley! Kingsley! What is your favorite equation?
Michealis-Menten equation.
What is the Michealis-Menten equation, and where did it come from?
The Michealis-Menten equation came from some very smart scientists. In 1913, two scientists by the name Michealis-M and Menten M.L. created the Michealis-Menten equation to describe the enzyme-substrate reaction.
But biochemistry student Max Moritz, why is that important?
Let me show you why. Enzymes are a special protein that bind to a molecule called a substrate.
But what's an enzyme and a substrate?
Good question, fellow student. An enzyme is a protein or a chemical that lowers the activation energy for a reaction. Whereas a substrate, it can be anything, any old starting material that the enzyme can do work on. For example, like after a big night on the town, there's an enzyme in your liver called alcohol dehydrogenase, which turns the alcohol that you drink that night into acetaldehyde. In this example, the alcohol dehydrogenase is the enzyme, your substrate is the alcohol, and the acetaldehyde is the product. After that reaction, there's an enzyme called aldehyde dehydrogenase, which takes our acetaldehyde, which is a very nasty chemical, and turns it into carbon dioxide and water, which is harmless. Now the product from the previous reaction turns into the substrate of this one. The enzyme catalyst reaction can be described with this equation right here, with E plus S, which is in equilibrium with ES, which can turn into E plus P, where E is your enzyme, your S is your substrate, ES is your enzyme binded to your substrate, and P is your product. So throughout the reaction, the concentration of ES stays relatively the same. So because of that, we can actually create an equation that's based on the formation and the breaking of the concentration of ES. So through a series of rearranging and mathematical equations, we can actually convert that previous equation into the Michealis-Menten equation, which we can see here.
But what does the plot of the Michealis-Menten equation even look like?
Well, fellow biochem student, that is a great question. Right here, we have the plot of the Michealis-Menten equation, where on the y-axis, we have the rate of the reaction, and on the x-axis, we have the concentrate of the substrate, often used in molarity. But why is this so important? Well, you see, this equation actually can tell us the rate of reaction of an enzyme, as well as its Vmax, its half Vmax, and its substrate affinity, also better known as the Michealis-Menten constant.
You see, the Vmax is a lot like petting dogs. If I pet one dog, it's a good time. If I pet two dogs, it's an even better time. But my Vmax would be petting two dogs because I can't get a third arm to pet a dog. And where your Km is the infinity for a substrate. So the way that you get it is from measuring your Vmax to your zero on your y-axis, or your reaction at zero. And you can determine your half Vmax, and from there, you cross it over until your line and go straight down to your x, and that will give you your Km. What isn't an infinity though? An infinity is how much a substrate is attracted or likes to bind to something. It's kind of like how I like deer. Come here, deer.
What's the difference between competitive and non-competitive inhibitors?
Well, that's a great question, fellow student. As you can see here, the competitive inhibitor actually changes the shape of the graph, where half the Vmax is the same, but your Km is changed. But notice, you still get the same Vmax, and the reason for this is because at higher substrate concentrations, it actually, like the substrate overtakes the inhibitor. See, but whereas the non-competitive inhibitors change it a lot more, where it has a lower Vmax because non-competitive inhibitors change the shape, so the substrates aren't actually able to interact with the enzyme. That's also why you have a half Vmax, which is different. But because the Km is the same as their normal graph, that means it has the same affinity as the original graph.
And that is the Michealis-Menten equation, the equation that revolutionized enzyme kinetics and changed the field of biochemistry forever.